All right, KNES 415. This is just a quick little check-in and micro lecture. I'm going to be back in town for class on Friday. So remember, you have all your lectures posted for you, but I am available for questions, clarifications. Just text me or email me, and we could find a time to work it out. Today's just a little micro. It's not going to be long, but I really want to emphasize the trigonometry. Okay. So let's say I use this pin to represent like a resultant vector, so like an arrow with a magnitude and direction, right? So if we're at from the horizon, I don't know if the camera is going to mirror me or not. So that's, point to the right. I may point this way, my video may point that way. I forget. But I'm hoping that it matches up well. So let's say the tip of this pin is in the horizon, from the horizon. So basically positive x or 0. And the resultant is the length of this pin. So we can look at it as a displacement, 10 miles, or I think in class I used the basketball goal, 10 feet. But it could be any resultant, 75 miles an hour, 100 pounds of force. Resultants are just magnitude and direction. So the magnitude is the amount, the direction is where is it being applied. And as we know, with angles, there's this combination of x and y, and in the human body, there's a combination of x, y, and z, but we keep it in 2 dimensions to make it easier. So what I really want you guys to understand is that at positive x, positive y, negative x, negative y are only 4 points in 360 degrees of application. And again, that's just in 2 dimensions. It gets infinitely many more when you work in 3D. But only 4 points is all of that magnitude in a straight line. More often than not, your resultant is going to be in some combination of x and y. And only x forces influence x motion, only y forces influence y motion. So that's why trigonometry is so important for us to see. Not necessarily to solve, but just to see, to visualize. I use this in class, but if you're doing a vertical jump and you notice that your athlete is jumping and then they go forward, there's wasted energy there. They're not putting all of their energy, all of their effort in the up when they drifted across. It's a little bit of an angle there, okay? So some of the things from the previous videos you need to understand. In quadrant 1, from 0 to 90, the component of the x will be positive, y will be positive. If you're at 45 degrees, that's halfway, right? 90, 45 is half of 90. At 45, the x and the y will be the same magnitude, right? Because you're halfway. So whatever is x is going to be equal to whatever is y, but these two will still be more than the resultant. We talked about that's because Pythagorean a squared plus b squared is equal to c squared, not a plus b is equal to c. From here, if the magnitude is more shallow, less than 45, x has to be greater than y. It's just kind of common sense, right? And if it's steeper than 45, y has to be greater than x. That's it. And then if we go past 90 into quadrant 2, from 90 to 135, or if we go relative 45 degrees past 90, y has to be greater than x. The up has to be greater than the across. At 45 degrees past 90, well, then they're going to be the same. And then shallower from there, the x is going to be greater than y. Guys, this is visual important. Like, again, you're trying to work on someone's release. You're trying to work on someone's form. You're trying to work on someone's, in football, where to push. It's all about angles. More up, more down. You're working with someone in CrossFit. You're working with someone in fitness. You're going to have to communicate these strategies, and it's all about magnitudes, forces, velocities, distances, displacements, and angles. How to apply these things. More up, more down, more front, more back. So I just need to be able to see that. Um, and so quadrant 3, quadrant 4. Newton's third law of action reaction kind of plays into this too, because if I'm supplying a force to the ground, like say in quadrant 3, so pushing on the ground down and to my right, well, then the ground has no choice but to provide a force up and to my left. So easy way to look at this is if I'm jumping forward, I need to push on the ground down and back so that the ground can push me up and forward. Make sense? So if I was jumping in a sand pit, I wouldn't go as far because as I push down into the back, I'm literally sand down into the back. So there's less reaction pushing up and forward on me. So another main part of class is that we are bound by our environment. Like I don't move myself. I need the ground. I need a fixed surface. I need a track. I need a court. You go play basketball on a dirty court, you're sliding all around the place, right? You got to wipe your shoes, wipe the court, because you're giving energy onto the court at angles, down and to the right, left, front, back. And the court is giving energy force back on you, up and to the front, back, left, right. Okay. So I think that's kind of important too on the Newton's stuff. So you guys just please let me know if you have any questions or clarifications, and I'll see you later this week.